Now here we are finding that economic order quantity or your inventory model with back order or shortage. Here will be, in this case, we have to see one more thing, that is CS. The point is, classical model normal is 2D CO by CH, but along with that we need to multiply an extra quantity, that is CS plus CH by CS. What is CS? CS is shortage or backordering cost, because due to high price of the item, we do not want to keep the whole lot. We want to keep some less amount, and that is shortage, and that is back order. So that cost of that back order, due to shortage, you will be having some cost, so you will be requiring to multiply this factor. Now maximum or number of back orders will be S star Q star minus M star. What is M star? M star is optimum stock level. The stock level, actually the maximum inventory level also, you can say they both are same, which you can keep. This is the formula. This formula you should look at. This is formula. So here what you have is CS plus CH by CS. CS is shortage cost and CH is carrying cost, but here it will be just reverse. Now coming to, if you directly want to find out the maximum or optimum back order size, then you can do one thing, this Q quantity star into this amount, CH by CH plus CS. This topic you need to remember the formulas. Now optimum order cycle, that is maximum, what is the number of, what is the cycle, means time, what is the time from one order to another order, this will be the formula, and we can convert it to multiplying by days, working days. If you write in days, then it will be, this is the formula, and if you write in year, it will be the formula. Now come to optimum number of orders, that is N star, it will be D by Q star, just opposite to this, and this is number of orders. And now this portion is not there, this is actually by mistake it is printed, sorry, this portion should be deleted, because we are actually dealing not the production, we are dealing the backorder concept, so we don't have that. So now what we have is cost will be 2D into CO into CH as usual, but again the factor is not just the reverse of this. And if you want to have total optimum carrying cost, inventory cost, not carrying cost, inventory cost, you have to add the fixed cost, that is cost of the item into the annual demand. This is the annual cost of the item. Annual, you always prefer the annual concept. The time frame is a little bit difficult, which time we will consider. I always prefer annual concept, annually how much you are spending. Now comes to the question. Annual demand for the article is 10,000 units. Ordering cost is 10 per unit, per order, mind it, and price of the item is rupees 20. Next is inventory carrying cost is 20% of the value, that means 20% of your 20 rupees, 20% of 20 rupees. And then the question, what would be the optimum number of units of the product to be bought in a lot if do not have any, allow any stock out. That means we are not allowing back order. And if the firm allows the back order, then what will be the cost? If the back ordering cost is 25% of the inventory amount, value of the inventory, 25%. And now the decision you have to take, whether you will use the back order or not, that is the question. And also you are asked how much quantity you like to keep back order, means shortage, how much shortage. In this question, D is 10,000, the annual demand. CO is rupees 10, just now we have seen, ordering cost rupees 10, and then carrying cost will be 20% of rupees 20. 20 was the price and 20% is rupees 4, and that value of the shortage cost will be the 20 ka 20%, 20%, 20%, that is not 20%, that is 25%, that is a mistake here, because back order cost is 25%. There is a mistake again. This is 20% for the carrying cost and 25% for the shortage cost. That is, if you use the back order, then back order means shortage cost will be this. Now first question, without any back order, you just calculate as usual. The first question is D into CO by CH under root, basic formula, and we got the quantity ordering, quantity per order will be 223.6, but it's 224 we can take. Now if you allow the back order, that is if you allow the shortage, then your formula we have discussed just before, that this is the formula we can put here, formula. And when we put the formula here, sorry, CS plus CH by CS, 5 plus 4, already you have found 5 and 4, CS is 5 and 4 is CH, and putting in it 300. So quantity is now 300. So you are now, since you have the provision of some shortage, you are taking 300 quantity units. Now the two costs, if you, they both are variable cost. I am not considering the total cost. Exactly same answer will come, means same conclusion will come, not same answer. Without stock out, that means if you directly find out, this is 894 rupees. This is rupees 894. Rupees 894. This is rupees. And then if you use the stock out, then the formula will be 2DCO into CA is the same one into this one. That means reverse of this, 5 by 9. 5 by 9 into 669 rupees. So now this without stock out is 894 rupees, and with the help of with the provision of back order, you will be seeing 666 rupees, 666 rupees. So obviously you are gaining. So it is better to reduce the cost of inventory. So we prefer the policy of back ordering. Now how much maximum back order you can take? S star, it is the optimum shortage, that is Q star minus M star. You can find, I have given the formula, but I think this is not good. You can directly find out with the help of this, Q star into CH by CS plus CH, that is CH is 4 and this total is 9. This comes to 133.3. This is your optimum shortage. So obviously your optimum maximum inventory will be obviously 300 minus 333, 133 will get the M star, that is the optimum level of this one inventory. Now the next model is both EOQ model, that is inventory model. I think this is better heading will be inventory model, with both shortage as well as production. Both are there. We are producing as well as we are keeping some shortage. So formula will be just clubbing the previous two formulas, shortage formula and production formula. Both formula if you club, then you look all the formulas. This is the EOQ, this is classical EOQ, this portion. Multiplying these two. Now here also you are multiplying this and this two quantities. What you need, you just only thing you need, you remember the formula and you link it. This S star, previously just now backorder case, S star is your this Q star into CH by CS plus CH. But in this case, what is happening? This into production factor, P minus D by P. That is the point. It is reverse of that. And next, maximum level of inventory, which is Q star minus S star. Q star we have found. This is called Q star. This is your Q star. This is your Q star, because what is you are finding? Q star means the quantity you are. Q star means the quantity you are actually using. Quantity you are using means that is the concept. Q, not dash, sorry, this should be Q star. Yes, Q star is this for EOQ. Now S star is Q star into this amount, and maximum inventory is this Q star minus S star, and optimum level of course you can find out. This is also another formula. This, I think this formula is not required, because this formula is I think this is not very important, because you this is M star. This is also M star, because this M star, what is M star? That is maximum inventory level, or maximum inventory you are holding after allowing the shortage. This is the same answer. Now optimum order cycle, Q star by D, obviously you know that is the classical concept, normal concept, and number of orders, optimum number of orders will be just opposite to this. Now what is the total variable cost? Total variable cost is as usual, but this factor will be multiplied. So total cost will be fixed cost plus variable cost. Now come to an example. The example is like this. The cost parameters and other factors for a production inventory system of an automobile pistons are given as: demand per year is 6,000 units, unit cost is rupees 40, setup cost is rupees 500, holding cost per year is rupees 8, and production rate per year is rupees this unit, not rupees, 36,000 units are there. Shortage cost per unit per year is rupees 20. Now you are asked optimum lot size, that is EOQ, optimum lot size. This wordings, what is the meaning? The wordings, optimum lot size, that is size of the order. Optimum lot size means size of order. Optimum number of shortage, manufacturing time, since it is a manufacturing process also along with shortage, and manufacturing time, after that time between setups, that is the time interval. Now you have total demand, you have cost of item, and you have ch means this carrying cost, and also cs is here in rupees 20. And now P, this annual production is 36,000. I have a suggestion, since it is considered both production and demand, so better we consider with capital D also, you can do. But you can convert it to daily by dividing with 300. 300, how do you know? That is the point. 300 is what? I have taken the working days annual is 300. That is our benefit. So small d is daily demand is 20 units and daily production is 120 units. Normal concept, always remember P is greater than D. Production should be greater than demand. Now first question, formula 2D into CO by CH into CS plus CH by CS and P by P minus D. Putting all these value you get 1123. Next is A star, that is shortage. Shortage is this quantity which you have found just now into P CS by CS plus CH, that 8 by 8 plus CH by CS plus CH, that is very important thing, into P minus D by P, and then that is 267. This is the shortage, so 1123, and among that, inside that 1023 units, your shortage will be 267. You will not actually order to 1128.3. That is the inventory level you are trying, but actually what you are doing, we are keeping some shortage to get a less cost, which I have said before. The cost of formula for cost is given here. If it is asked, we can find out. And then they have asked two things. One is manufacturing time, that is Q star by P. P is annual production. So this is 0.03 year, 113, that is a this is a EOQ size. EOQ size is 1123 divided by 36,000 is production. So what is the manufacturing time? 1123 by 36,000, if you divide, is 0.03. If you want to convert to days, it is 0.03 into 300. It will come, you will get 9 days per approximately. And on the other hand, the next question, that is the last one for this, time between setups. Time between setups means one order to another order. Q star by D, you are getting 0.19 year. That means if you multiply with 300, it is something like 50 or like that, 58 days approximately, like that, the approx. So I am giving the answer in year. It is your choice. So this is all about what we have discussed, the concept of this one. I can say two models. Actually, we have discussed two models.